So this is asking you about a core practical that we do in year 10. It's looking at the reaction of calcium hydroxide with dilute hydrochloric acid. And they're giving you a method in which they're going to carry out this experiment. And this question he's asking about step 2. So I'll quick look at step 2. So step 2, we're adding the calcium hydroxide to the beaker. And it says, how can you make sure that this reaction is complete? So what we did in class is we actually stir the beaker to help it to react, and that encourages the reaction to take place as fully as it can. Complete the word equation for this reaction. So in here, they're not giving us any clues. So what we have to remember here is that we have got acid and a base, and if you remember, this makes a salt and it produces water. So the salt is a metal salt. The first name comes from the base, so it's calcium. The second name comes from the acid, and because it's hydrochloric acid, it's going to be a chloride, and then we get water on the end. There's 2 marks there, so what they're going to do in that question is give you 1 mark for that part and 1 mark for that part. Which shows the state symbols. Okay, so we were told that the calcium hydroxide is powdered, so that means it's a solid, so it's going to be those 2. And the acid is a solution, and AQ means solution, so the only sensible option in there is option C. Let us continue. So here's our results of the experiment. Let's just remind ourselves what's going on in here. So here at the moment, in this region, this is where we have got an acid, and this top end up here is where we've got alkali, and in the middle, this region here, this is where it's changing the pH. But interestingly, there's pH 7. If you remember pH 7, that is where it's gone through the neutral stage. Okay? So it says, use figure 12 to give the pH at the start of the experiment. So if you work out your scale, and this one is halfway, so it's going to be a little bit easy for us, that's going to have a pH of 1 at the very beginning. Use figure 12 to calculate the mass of calcium hydroxide to make it neutral. Okay, so this is where we need to remember that pH 7 is neutral. So I'm going to come down from that point there, and that's the point just there. And I've gone through 2 squares, so each square is 0.2. So that is going to be 0.74 grams required. Okay, so to explain why the pH starts off as acid and changes. Okay, so if you remember, acid, the reason it's acidic is because it's got a lot of hydrogen ions. So at the start, it is acidic as there are lots of H plus ions, lots of hydrogen ions from the solution. During the reaction, H plus ions react with OH minus ions from the base, the hydroxide ions. So that is going to reduce, this reduces the H plus ions. Okay, if you want to show off, you put the equation in. So H plus OH minus makes H2O. So that's neutralizing it. At the end, let's specify that part. At the end, there is an excess, too many OH minus ions. So the pH is high. Okay, makes sense? So if you keep adding the hydroxide ions, they're going to react with the H plus until there's none left. Hydroxide ions take the pH above 7, so therefore your pH goes up. Marks for this, So at the start, we've got that. At the end, we've got that. And in the middle, we've got this reaction taking place to neutralize the H+. Carrying on, what we've used to measure the pH of the mixture. So in a perfect world, you would use a pH meter, so you get a digital reading. In class, when we did this one, we used universal indicator, and that allowed us to see different color change for each pH value. Calcium hydroxide is corrosive, so what do you do? So in class, when we did this one, we had eye protection, and the people in the group that were using the calcium hydroxide also wore gloves. You need to get one of them for the mark.